have a little extra time. Is there any questions with section 1.4? No. Very good on those? Yeah. Okay. Okay. So then let's dive right into 1.5. Will be in your white note packet on page, I want to say that this is 15. Okay. So on page 15, if you would do the retrievals, 1 and 2, yeah. So it looks like in 1 we're finding the rate of change in the representation, and then using the explicit equations H and D to find some output values. Okay, give you a few minutes to do that.
Okay. Have it?
Well, it'd be a 0 in the grade book, so you have to check that. Yeah. All right. So on table, how do I find the rate of change? Okay. Where am I looking? In the table, where am I looking for that common difference? So I'm looking on that G of n column, and that output column, right? Okay. We talked yesterday about how this column here would be our inputs, and this column here is our output. So we're really looking at that output column, right? Okay. And so we're looking at that if there's a constant rate of change going from consecutive inputs. Yes? Is there one on this one? Yeah, what is it? Subtracting 3 each time, right? Okay, I like that. And so that would make our rate of change for this one -3. Okay. How do I find that on the graph? Because the graph is the same as the table. So on the table, we just looked at the outputs. How do I find it on the graph? Right, run. It's the slope. Yeah, exactly. It's the slope of our line. Okay? And so what we're looking at here then is we're looking at our rise. So we went to go from this point, we went either up 3 and left 1, or we went down 3 and right 1. In either case, that fraction, that rise over run case, that slope of that line, or the slope between those points, is -3. Okay? Love it. H of 4. So we're going to plug 4 in for t in h's function. So that's going to be 5 times 3 to the 4th power. 3 to the 4th power is 3 times 3, which is 9, times 3, which is 27, times 3, which is 81. So that's going to be 5 times 81. So that's going to give us h of 4 is 405. D of 2, now I'm going to put 2 into my D function. 7 minus 9 times 2 minus 1. 2 minus 1 is 1. So this is 7 minus 9 times 1. 9 times 1 is 9. So that's 7 minus 9. 7 minus 9 is, so D of 2 is -2. Love it. Okay. H of 0, I'm going to plug 0 into my h function. 5 times 3 to the 0 power. Anything to the 0 power is 1, so that's 5 times 1. So this is h of 0 is equal to 5. Okay. D of -3, so that's going to be 7 minus 9 times -3 minus 1. -3 minus 1 is -4. -9 times -4 is?
Oh, positive 36.
Negative times negative is positive, so then this becomes 7 plus 36. 7 plus 36 is 43. Questions, comments, concerns, clarifications on those? Good. All right. Let's jump into today's notes. So then that way Jackson puts his homework away so that he can pay attention to what's going on today, so that he doesn't get lost today and he's got to do his homework tomorrow in class. Okay? All right? So we are sitting here. Maybe you've gotten an email like this in the past where Bill Waits, founder of Super Scooper Ice Cream, is offering a gift certificate for our signature Super Sundae, an $11.95 value if you forward this letter to 10 people. When you have finished sending this letter to 10 people, a screen will come up. It will be your Super Sundae gift certificate. Print that screen out, bring it to your local Super Scooper ice cream store. The server will bring you the most wonderfulest ice cream creation in the world, a Super Sundae with 3 yummy ice cream flavors and 3 toppings. Okay? This is a sales promotion to get our name out to young people around the country. We believe this project can be a success, but only with your help. Thank you for your support. Sincerely, Bill Waits, founder of the Super Scooper Ice Cream Company. These chain emails rely on each person who receives the email to forward it on. Have you ever wondered how many people might receive the email if the chain remains unbroken? To figure this out, assume that it takes 1 day for the email to be opened, read, forwarded, and received by the next person. Okay? Right? So it takes 1 day for one person to send it to 10 people, or to read it, send it to 10 people, and then get received by those 10 people. Okay? So on day 1, Bill Waits starts by sending the email to his 8 closest friends. So on day 1, he sent it to 8 people. With me on that. Okay? Each of those 8 people then did what with the email? They forwarded to 10 people. So how many people on day 2 are reading the email and forwarding the email? 80, because each of the 8 sent it to 10 more people. So now on day 2, that's where the 80 people comes in. Okay? So now on day 2, those 80 people send it to their 10 friends. How many people have it now on day 3? 800, right? Okay. Do we see the pattern developing? Yes? Okay. What is our recursive formula? Meaning, how do we find the next term? So we're multiplying each time by 10, right? Do we all agree that we're multiplying by 10? Yep, okay, all right. So my recursive is 10 times the previous, yes? Okay, so 4th day, how many people? 8,000. 5th day, 80,000. 6th day, 800,000. And 7th day, how many?
8 million.
8 million people, yep. Okay, so 8 million people would get that email on the 7th day. On the 8th day, and 800 million, then 8 billion. Okay. All right? So in number 2, It's asking how many people will receive the email on day N. Which kind of a formula is that one looking for? That's looking for an explicit formula. Okay? So now, is this linear like we had yesterday?
No.
Why not?
Because it was a yes. So
I never said it wasn't yes, though.
was that a trick question?
No. I'm literally asking, is it linear? No trick involved at all. Linear was yesterday. Makes a line. What do we know about a linear function?
Like the numbers, like they all like add to the same thing.
Close. Can we clean that up a little bit?
Like they go down the same.
So we're always adding at a constant rate of change, right? Okay? Right? So we're always adding the same value, okay? So in this, on our chart here, from day 1 to day 2, we added 72 emails. I was trying to think of how I could call it. 72 people opened the email, right? From day 2 to day 3, did we add 72 again? No, we added 720, right? Okay, so that's not the same, so it's not linear. Okay, so everything that we learned yesterday only works for linear functions, where that's a constant rate of change, a constant or a common difference. Okay, so today it's geometric. Okay, so the geometric part is going to come in now here with what we're going to do is we're going to have to come up with an explicit formula based off of that. Okay. So our explicit formula is going to be f of n is going to equal some output times our ratio to the n minus the input power. What I mean by that is, off of our table, we could have 7 different equations there. Okay? So for instance, let's say I chose this one here as my starting point. Okay? So my function then would be f of n is equal to, my output is 800. My common ratio is this right here, what I'm multiplying by to get the next term. Okay? So my ratio here is 10 to the n minus 3 power. Okay? Because if I stick 3 into that function, 3 minus 3 is 0. Anything to the 0 power is 1. 1 times 800 is 1 times 800? 800, right? Okay, right? Let's check it with a different one. Let's check it with 5. 5 minus 3 is 2. 10 to the second power. 100. 100 times 80. Or excuse me, 100 times 800. 80,000, right? Add 2 more zeros to it. 80,000 was what we had for number 5. Okay? Let's say you didn't want to use that one. Let's say you wanted to use this one. Okay, your first one. Then your function would be f of n is equal to, my output is 8, my common ratio is still 10, but now it is n minus 1. There. And that will also work. Mr. Tipple, do you find it easier to have your back to where all of the information is being presented? Or do you find it easier to see what is being presented? Okay, me too. I just wanted to make sure that, you didn't learn in a different style. Okay? All right? All of those work. It is not your job to come up with the one that I like. Okay? It's my job to make sure that the one that you come up with works. And if you follow that pattern, those will work all the time. Okay? I don't think there's anything more on that page. Nope. Okay. Although offers like bills are usually scams, let's think about what would happen if you really did give away all the ice cream offered in the email. Now here's what I don't understand. Here it says that in this one, if Bill gives away a Super Sundae that costs him, because of the markup. Okay, I get it, the markup. Got it. Because on the first page, didn't it cost him $11.95, or didn't he say it was an $11.95 value? Here it's only $4.95, so he must mark it up $7 a Sunday. Just making money, getting people ice cream. Okay. How much will he spend during the first week? How are we going to figure that out? We're just going to talk about it. We're not going to actually do it. This is a pretty big number. The days of the week times something? So like 7 times $4.95? Do we agree with 7 times $4.95? I see more heads shaking side to side than vertically. Okay, come up with an alternative. Okay, why would you explain your rationale?
Because in a week it was 8 million people that ended up buying
The coupon?
Yeah.
Do you agree with her now? Yep, I like her. I like hers better. Not the day of the week, but how many coupons would be. So 8 million people would cash in that coupon at $4.95. Anybody with a calculator? 8 million times 4.95. It's going to be a pretty big number. Should be in the 30 million range. Actually, it should be more than that. It should be almost close to 40 million. Anybody? 39,600,000? Okay. So that's how much it would cost them if everybody cashed in after a week. Okay? So that's pretty big coupon. Okay? So that common ratio we can find in a couple of different things. One thing that I haven't been doing yet, and I should be doing, is on our recursive equation. So let me go back here to this recursive equation because I just remembered myself that I've got to start doing this. On our recursive equations, we're saying that the next is equal to 10 times the previous, right? Or that would be also f of n equals 10 times f of n minus 1. Do we agree with that? Written in function notation. Okay? I'm good with that. Okay? But what I've been failing to tell you to do is we we got to set a starting point for it. So we either have to say f of 1, comma, f of 1 equals 8. Or we have to say f of 2 equals 80. Or we have to say f of 3 equals 800. Or we have to say f of 4 equals 8,000. Okay? Just because we got to know what number, we need one number somewhere in the sequence so that we set. We don't just multiply any number that we want by 10. Okay? Questions on that? Okay? In a table or in a sequence, it's dividing any output by the previous output. That gets us our ratio. Recursive gets us there. Explicit gets us there. All good there. Love it. All right. What do we got next? Shabam! Ready, set, go on pages 14 through 17. Let's just take a quick sneak peek at that. This is your homework now, yes. Yeah. See, if you were looking in this way the whole time and paying attention, okay? Right, so if I'm looking at the homework, so I'll just briefly go through it. 1, 2, 3, and 4 are like those graphs, okay? Where the table and the graph are the same. You need to show me how to find the rate of change based off of on both. So show it to me how you do it in that table and what it is, and then match that up with the graph and what it is. Okay? 5, 6, and 7 are coming up with those patterns and then finding the explicit and the recursive equations. We can handle that. 8 and 9 are graphing 2 points and finding the slope, rise over run between those two. 10, 11, 12, and 13 is kind of where what I want to talk about here now. So if you turn to 10, 11, 12, and 13, which is on page 17, okay? First thing it's asking for you in all 4 of those is it's asking for you what the slope is. How do we find the slope of a line now? Rise over run again. We look for points that the line goes through, and there's many a point that those lines go through. We're talking about those right now. Okay? All right, so we find the rise over run there to find the slope. What is B? B is the y-intercept. What does that mean? Where the line crosses the y-axis. Yep, exactly. Where the line crosses that y-axis, that's your B value there. And then the equation that we're looking for, what's the general form of the equation? And everybody should write it down so they all write down the same one. Y equals mx plus b. Yep, there. Okay? With me? Stamping is open if you have anything to get stamped. I also have to hand back to you your quizzes, and I'm going to do that right now. And you can either start correcting those right now, or you can do your homework right now. I don't